Hello friends, once again this is Ranjan with another design in CST Microwave Studio. Today I will show you Aperture coupled Dielectric Resonator antenna, a recent approach, and it will help you a lot to design any dielectric resonator antennas. Usually, what is a dielectric resonator antenna? It is having a dielectric material, high dielectric permittivity, it is having a high epsilon value, and there are numerous type of feeding techniques, and aperture coupled feeding is just like that. It is having a slot or any aperture in over the ground plane, and above that the dielectric is situated, and below the substrate we have a microstrip line feed, and it will couple the slot and excite the dielectric resonator. Then before going to the design, you should know few things about dielectric resonator antenna, how to calculate the resonant frequency, and the mechanism of electric and magnetic field propagations over the materials and all. Then this is another kind of feeding technique known as coaxial feeding technique. This is the dielectric resonator antenna, and we have a coaxial probe, as usually we are giving a coaxial probe to the microstrip patch antenna. Then this is the usually this is the main equations using which the equations or the resonant frequency of a dielectric resonator antenna is being calculated. It is known as dielectric waveguide model of dielectric resonator antenna. You can find it everywhere in internet. Okay, then this is just a view of HFSS model showing the field distribution of a coaxial feed rectangular dielectric resonator antenna. Okay, then this is also a cylindrical dielectric resonator antenna photocopy. We can also design this kind of antennas. Okay, now come to the business. This is the rectangular antenna. Today I am going to show you a design of this antenna. The antenna is something like this. We have a substrate. Over that substrate we have the ground plane, and then below the substrate we have a microstrip line feed, and the feed extend up to this point, and then we have a slot. We are giving the excitation by a coaxial cable or a SMA connector here, and this microstrip line will excite this slot, and then the dielectric resonator antenna will excite it. Okay, this is a different kind of view. You can show it. This is the dielectric resonator, this is the slot aperture, and below the substrate we have our microstrip line. Then let's go to CST Microwave Studio. Use the same template as we used in the previous lectures in our microstrip patch antenna. Okay, let's go. I have already fixed something like I have already mentioned the frequency range. I am going to design the antenna from whose bandwidth lies in between 4 to 7, and then I have already mentioned the parameters. I will just show you one by one. One is I have named as E, which is the extension of the stop, means this one, extension of the stop from this point to this point. This is the extension of the microstrip stop for this is for the impedance matching. Then I have H is the height of the substrate, H1 height of the DRA, then L height length of the DRA, length of the slot, then inner radius of the coaxial cable or SMA connector I am going to use to feed the microstrip line, then outer radius of the coaxial cable or the SMA connector, then the thickness of the metal or the copper I am going to use, then width of DRA, width of the slot, width of the line. Okay, then I will show you the steps one by one. So press on brick, press escape, name it as substrate, then define the range x minimum and x maximum. Here I will mention it in the x-axis as twice, in the negative axis, and twice in the positive axis at the length of the DRA. You can take larger than this, there is no restrictions. Okay, so and the width I will take 3 times the width of the antenna. Okay, then the height is nothing but minus h means height of the substrate. Then I will assign a new material. I will name the material as substrate mat. Then I will put the value of the epsilon 3.38 according to our Roger 5883, and you can take something else. Okay, and I will give a color, any color as per your wish you can give it. Okay, then I'll put OK, then I will put preview, then OK. Yes, we do have, oh sorry, actually the color is some kind of transparent, so I will reduce the transparency. Then I will start my design. Okay, then I will go a little bit speeder because I want to control the length of the video. So I will select the upper face of the substrate. Since we are going to design the ground plane over the substrate, then I will as per the previous video I have already told you, you can put it at extrude, and I will name it as ground and give a height of T. Here T is the metal thickness. Okay, so I will load from material library and I will select copper. Okay, then I will select load. Okay, then OK. Yes, we do have a copper. Then I will select the midpoint of this edge. Okay, then I will align the local coordinate with the point. Then I will move the local coordinate or transform the local coordinate, transform the local coordinate in the positive u axis 3 times the length of the dielectric resonator antenna. Okay, I can see the preview. Yes, okay. Then I will again move the local coordinate to the back side, so it is in w axis minus h and minus t, height of the substrate and as well as the height of the ground. Then I will, so what we have to do now, I will just transform the local coordinate in w axis, that is minus t and minus h. T is the thickness of the copper layer above the substrate. Since I want to design a microstrip below the substrate, so just press OK. Now it is at the back side, so press brick, name is transmission line. In u axis I will put minus 3 into length of the antenna. Then in V axis minus WT divided by 2 WT divided by 2. Okay, so in W axis I will put minus T because I want a copper layer above below the substrate. Okay, then press OK. Now you have everything. So now I will move the local coordinate. I'll move it in first in W axis. I will take it over the substrate, over the ground plane. So I will press minus H plus T. Okay, then apply. Then I will move it in U axis, positive U axis, that is minus WS by 2. That is WS is the width of the slot aperture I want to make to excite the dielectric resonator. Then minus E, where E is the extension of the stop I have already mentioned here. Okay, so I will press apply. Okay, then I will go to the upper side. Okay, this side. Then I will press brick, escape, name it as SLOT slot. Then we'll go to U minimum and U maximum. In the U axis I will put the width of the slot, that is WS. So I'll put minus WS by 2, WS by 2. In V axis, the width, yes, the width along U axis, length along V axis, yes, minus LS by 2 tab LS by 2. I forgot to put a minus sign here. Okay, so I can see the preview. Is it there? I think I should zoom it to see. Yes, I think it is there. So I will mention a different material, whatever the material is. Okay, choose any type of material because I want to just cut the shape away. Okay, I am above the ground, so I will define it minus T. Okay, we'll see the preview, then press OK. Then shape insertion dialog box will appear. Just click cut out the highlighted place, then OK. Yes, now we have a slot, you can see it. Okay, then I will select the edge I want to define. Yes, I will move the WCS, I just pick the edge here and I move the WCS to the midpoint of that selected edge. Then I will move